Okay, this is the P2 paper from January 2023. It's question number 4. As you can see, this is a laws of logarithms question. We're going to be solving an equation using logs, and then the second part is using the sigma notation, which is sequences and series. Okay, let's have a look at part 1 first of all. Part 1 says, use laws of logarithms to solve log base 3 4x plus 2 is equal to log base 3 5x plus 7. Now there is more than one method for doing that. I'm only going to show you one here, but there are other ways that you might want to look at doing this. What I'm going to do is I'm going to collect together the logs on one side. In fact, I'm actually going to do it the other way. I'm going to collect together the logs on one side, use the log rules to make that into a log statement. A single log is equal to, and then I'll get rid of the logs and have some sort of equation to solve. Rather than talking about it, let's get on and do it. So I'm going to say, okay, so as I've just said, if I say 2 is equal to log to the base 3 of 5x plus 7 minus log to the base 3 of 4x. One of our log rules says that if we've got log A minus log B, that's the same as log A over B. So if that's true, I'm going to get that 2 equals log to the base 3 of the fraction 5x plus 7 all over 4x. Once we've got that, I'm then also going to use the idea that if we've got log to the base A of B equals C, I can change that into a power statement. The way that I do it always is to say, well, this is the base of my log, so it's going to be the base of my power statement. A logarithm is a power, so it's going to be A to the C equals B. And you should be able to go both ways between those. You should be able to start off with that one and end up here, or vice versa, start off here and end up with that statement there. So using that idea then, just tidy that up, let's put that just all in here. Using that idea, what I can do is I can now change this statement here, following the same idea. The 3 is the base, a logarithm is a power, so 3 squared is equal to the log of whatever. So in this case, 5x plus 7 all over 4x, and then that now is something really easy to do because it's just a straightforward equation to be able to solve. So if I need to solve that, that's 9 times 4x, that's 36x is 5x plus 7, so 31x is equal to 7. In fact, let's just go straight for it. X works out to be equal to 7 over 31. So solving that equation, not too bad at all. Let's have a look at this second part then. So this second part is going to be using my sigma notation, and they've basically told me that this is equal to this, and then what they're asking me to do is find y in terms of A. Well, what I'm going to do is I'm going to write out an expansion of that, an expansion of that, and then look at them. They're equal to each other. What does that give me? And we'll see how far we get when we actually do that. So let's have a look. Part B. So it said that we've got the sum between r equals 1 to 2 of log A and then y to the r is the same as the sum from r equals 1 to 2 of log A y all to the power of r. Okay, well, let's just do this. Do we remember the sigma notation? What this means, so let's just have a look at it. What this means up here is that I'm basically going to take this function here and I'm going to put r equals 1 in. I'm then going to put r equals 2 in, r equals 3, r equals 4, r equals 5. Keep putting the values so that we go from r equals 1, well, in this case, only to r equals 2. So I'm only going to have r equals 1 and r equals 2 in there, but we'd have as many as we needed to go from the bottom value to the top value. So saying that then, excuse me, that's going to be, on the left-hand side, log a y to the 1 plus log a y squared, y to the power 2. That's it. On the other side, following exactly the same idea, I'm going to have log a y to the power of 1 plus log a y squared, or to the power of 2. Okay, well, if I look at those then, let's just tidy that up, because I put all those things out. I really didn't need to put the ones in, did I? That's log a y plus log a y squared is equal to log a y plus log a y all squared. Well, the first thing we can do is we can say that that cancels with that. This log a to the y squared, this part here, that's using another of our log rules, which is if I've got log a to the n, that's the same as n log a, the power. Well, that can come down here and just be made simpler to that. So if we do that with this left-hand side, I'm going to get 2 log a to the y equals log a to the y squared. And now this isn't actually as difficult as it looks to solve here if we're actually thinking about this one. You just imagine that that's x there and that's x there. I've got 2x equals x squared. Okay, I've got 2 something equals something squared, and that's easy to be able to solve, isn't it? So let's get it over to one side. We'll say log a y squared minus 2 log a y is equal to 0. Well, I can take log a y out as a factor. Log a y out as a factor, which leaves me log a y minus 2 equals 0. So I either get log a y equals 0 or log a y equals 2, using exactly that same idea that we had. Did I get rid of it? Where's the, yeah, this bit here. Using exactly that same idea again, I can then say if log a y is equal to 0, then y is equal to a to the 0, which gives me y equals 1, or I can get y equals a squared. And if we go back to the actual question, what did it say? It told me, give the answer in terms of y is in terms of a, but it also said there that y is greater than 1. So let's make it really clear, not in range. So we don't want that one, but yeah, y equals a squared then is my answer. Not the easiest, I think, that one there. It's at this stage here realising, just put it in, see what we get and see how we tidy it up. I couldn't have quite so quickly predicted, for example, that those two were both going to cancel out, and then also to be able to see that when we get to this stage here, we've got that and then that squared. Yeah, let's see what they give us. But, you know, they're designing the questions for us to be able to do it, so I had every confidence as I was going through that I'd go so far and then I'd be able to look at it and say, oh, I can see what to do next. Right, hopefully that makes sense. You're not the most straightforward of questions, but hopefully you manage with that one.